This video is going to be the first of a few for section 3.3 in the textbook, in which we're going to be covering completing the square. So the question obviously is, well, what does that mean? What is completing the square? So if you think back to 3.2, whether you were in class or you saw the video, in that section we saw how to go from vertex form to standard form, and that involved multiplying some stuff out and simplifying. Completing the square is going the other direction. So it is, if we want to describe it technically, the process of going from vertex or from standard form to vertex form. And it's a little bit more complicated than going the other direction. Converting vertex form to standard form was pretty easy, just relied on some foiling skills. But this process is going to require you to memorize a bit more intense of a process. So just a quick refresher, standard form is y equals ax squared plus bx plus c. Vertex form is y equals a, and then we've got the brackets with x minus p squared, and then plus q. So our goal in completing the square is to go from this thing on the left to this thing on the right, but that's going to be a little bit trickier. So if you look, we need to somehow create brackets. This is the big thing. It's the square, right? This is why it's called completing the square. We're trying to get that thing. But the question is how? So, for example, a pretty basic question from this topic might say something like convert some function in standard form, like y equals x squared plus 6x plus 5, and we want to turn that into vertex form. That might be so we can find the vertex, that might be in order to graph, it could be for lots of reasons, but in general, we're going to be doing this a lot. So, going through some steps. The first thing we want to do is we need to group up those first two terms, so our x squared term and our x term. And we're going to do that with some brackets. So we would have something like y equals, again, x squared plus 6x plus 5. But we're going to put brackets around the first and second term, like so. It's a really easy, basic step. Second step, going on from there, is we're going to look at that second term. So in this case, that's 6x. And specifically, we're going to look at the coefficient of that term. So really, we're just focusing on the 6 right now. Okay. We're going to take that number, and we're going to do a couple of things to it. First, we're going to divide it by 2. And then we're going to square whatever we get from that. So for our particular question, that means we're going to do 6 divided by 2, which is 3. And then from there, we're going to take that result, which is 3, and we're going to square that to get 9. And so 9 is kind of the number we're focusing on. And so again, the 6 that we just worked with was just this coefficient up here on the 6x. Now that we've got that, we're going to take that number, so 9, and we are going to add it and subtract it inside the brackets. And it has to be inside the brackets. I'll get into the specific reasoning for this in a second. So for now, just trust me. All right. So that will look for us something like y equals x squared plus 6x plus 9 minus 9, and then plus 5. So these two 9s came from this 9 that we got up here. So the thing is, I don't actually really want that negative 9. It's the plus 9 that I'm interested in. But in order to bring in the negative 9, or sorry, bring in the positive 9, I have to counterbalance it with something on the opposite side. So we've got a plus and a minus to keep things fair. All right, Step 4. We're going to take that -9 and we're going to move it out of the brackets. So you might be wondering why we bothered to put it in there in the first place. It doesn't actually matter too much when we have a basic one like this, but for the more complicated ones, it will matter. And so it's better to get into the habit of starting with it in there and then just moving it out later. So for now, just trust me. All right, so we've got y equals x squared plus 6x plus 9, and that's all still in the brackets. And then we've got plus 5, and then that -9 that we've now moved out. We're actually almost done. So last thing we need to do now is to factor those brackets and simplify. If you don't really remember how to factor, that's okay. I'm going to teach you a shortcut for this in a sec. I will go through it for this one, but if you need a little bit more help with factoring, there will be some other videos that you can go check out, or you can come see me in class. So for this particular one, we need to factor that x squared plus 6x plus 9. So really quick refresher on factoring from grade 10. To factor this, you want to find two numbers that multiply to your c value and add to your b value. So we need to multiply to 9 and add to 6. In this case, that's going to be 3 and 3. And so we split this up into x plus 3 times x plus 3, which is x plus 3 squared. And that's really key. That's the thing that we wanted. Remember, this was called completing the square because vertex form has a square in it. So x minus p squared. For us, that's going to be x plus 3. And so our whole process that we've gone through was to try to get this perfect square right here. So our function now looks like y equals, our brackets is now x plus 3 squared, and then plus 5 minus 9 gets us minus 4. And that's in vertex form. So now we've accomplished what we set out to do. It's really helpful. Where this all comes from, for anybody that's curious, feel free to skip ahead over this if you're not super interested in the process why we're doing this. We're essentially trying to figure out a. Maybe I won't use a, that number we see too much. We're trying to figure out p, I guess. So if you squared x minus p, you'd get, x minus p times x minus p. And if you foiled that, we'd have x squared minus px minus another px, and then plus p squared. Or if you simplified that, x squared minus 2px plus p squared. And so our whole process here, we didn't know what this p squared was, right? This was unknown to us, so I'm going to get rid of that. But we had our first two terms. We had this. To go from whatever our coefficient was there, so our b coefficient, to whatever belongs over here, this is why we divided by 2. So you can see that 2p, if you divide it by 2, you'll get this p, and then if you square that, you'll get this p squared over here that we have. So this is kind of the process, the thinking behind that whole completing the square thing. Again, you don't have to necessarily know this, you just have to memorize the steps. So let's go ahead and give another one a try. We'll convert y equals x squared minus 10x plus 8. Right, so I'm going to go through these steps again, but I'm going to go a little bit faster this time because I don't have to write everything out. So step 1, again, not even really a step. We just need to throw some brackets around those first two terms. X squared minus 10x, and then we've got the plus 8 on the outside. Second step, we're going to take that middle coefficient, that negative 10. We're going to divide it by 2 to get negative 5. And then we're going to square that to get 25. You don't even have to show that. That's something that's absolutely just doable in your head. And I know before I broke it into a separate step, but usually I just combine the first few steps into one. So for us, we've got y equals x squared minus 10x, and then plus 25 remember the 25 coming from over here, and minus 25. And then we've still got the plus 8 on the outside of the brackets from the original function. All right, next up, we want to move that negative 25 out of the brackets. So that's y equals x squared minus 10x plus 25. And then plus 8 and minus 25. And then finishing things off, we factor those brackets, and here's where the trick that I mentioned comes into play. So to go from our brackets here to our factored version, this number here, so your p-value, is always actually just going to be half of what you had here as your b. So that minus 10, we're just going to divide that by 2, and we're going to get minus 5. And that's always going to work, so if you're not super fresh on your factoring, just remember that and it'll help out. It's also going to be great for situations where we run into fractions or decimals or just numbers that aren't going to be super fun to factor with. So here, we've got x minus 5 squared minus 17, and that is vertex form. So go ahead and try this next one out for yourselves. It's going to be the same idea. It should be a relatively straightforward one to deal with. So once you've got this down, go ahead and pause, give it a shot, and then come back to check your answer. We've still got one more to go after this. All right, so going through things again pretty quickly. So x squared plus 8x minus 9. I throw some brackets up there. 8 divided by 2 is 4, and then 4 squared is 16, so I'm going to add and subtract 16 in the brackets. Then I move that negative 16 out of the brackets. And then lastly, simplifying things. So x squared plus 8x plus 16. If you think of that trick that I just mentioned, all we have to do is take the 8 and cut it in half. So this is going to be x plus 4 squared. And then the minus 16 and minus 9 gets us minus 25. Now, you may or may not have noticed that the question had a little bit of an extra layer to it. So it wasn't just convert to vertex form, it actually asked us to find the vertex. So now that we're in vertex form, we just have to look at our function, and remember the vertex is at PQ. So for us, that means our vertex is at negative 4, negative 25. So you always got to think, what's the question actually asking me for? All right, last one. This one's going to have a slight bit more challenge to it, just because the numbers aren't going to work out quite as nicely. So y equals x squared plus 5x plus 8. And so if you look at that and you consider it for a second, you might realize that if we have to do 5 divided by 2, we're either going to get a decimal or a fraction. For this particular question, it won't really matter which one you go with. As a general rule of thumb, if you're going to end up with a decimal that you have to round, say you're doing something over 3 or over 7, then those should be left as fractions. But if it's a clean decimal like this, which you're often going to run into when you're completing the square, it's okay, you can leave it as a decimal, it's fine. So I'll do both, but go ahead and pick whichever one you feel like you're most comfortable with, run through this question, and then come back and see how you did. All right, so in our brackets, we've got x squared plus 5x, and then 5 divided by 2 is 2.5, and 2.5 squared is 6.25. So that's what I'm going to be adding and subtracting. I move the negative 6.28 or 6.25 out of the brackets, and I'll end up combining that with the plus 8 in a sec. And so simplifying all this, we end up with y equals, and this is where that factoring trick is really handy, because factoring, multiplying to 6.25 and adding to 5 is going to be pretty frustrating. But if I know that it's just going to be x plus 2.5 squared, I can just go straight there. If you simplify that stuff on the outside, you end up with 1.75. So there we go. You'll run into decimals, you'll run into fractions. It happens. It's not a huge deal. If we were to try this with fractions, it'll be a little bit more challenging, but the numbers won't be too bad. So looking at the same steps, we'll have x squared plus 5x, and then 5 divided by 2 is, well, 5 over 2. And if we square that, we end up with 25 over 4. So just a quick refresher for you, if you square a fraction, you just end up squaring the top and the bottom of the fraction, which is how we end up with 25 and 4. So I add that, I subtract it, I still have the 8 on the outside. Next step is exactly the same, we just move the negative term out. And then to finish things off, we have to keep in mind that we are trying to combine a whole number and a fraction. So remember, your fraction addition, you need to have common denominators. So I'm going to actually take that 8 and I'm going to swap it out. So our common denominator for 1 and 4 is going to be 4, and our 8 is now going to be a 32. So remember, you just have to multiply the top and bottom by 4 to make things match. So wrapping things up, we end up with y equals, in the brackets, it'll be x plus, and then again, taking the 5 and finding half of it, it'll just be actually 5 over 2, and then squared, and then 32 over 4 minus 25 over 4 gets us 7 over 4. And there we are. So that is how you complete the square. You might have noticed, though, that all of these vertex forms and all of our standard forms all had something in common. All of our a values were actually just 1 in these cases. So the next video is going to cover what it looks like when your a value is not 1. You'll find that that actually makes things a little bit more complicated. It adds a step and changes a step, so it's not a huge difference, but it does tend to lead to some mistakes. So go ahead and flip over to that one if you're interested. If not, you'll be able to find out in class as well.